is a factor of, at least 10 or 100 or something like that in signal noise. So it's taking, years and years of accumulation to get to understand these trends, so that'll help a lot. And the real thing that will help with is mapping. So it'll be nice to be able to make maps of this rather than plot slopes, which is, it'll be more intuitive, I think. Who can I do it?
Testing me here. I had a question related to Carly's comment. So when I was looking at the change that you had with time, was the depth and the effect the same for the Mare and the Highlands? Because this was one thing that was different. When we did the TPD, the activation energies are different in the Mare and the Highlands. Sticking of water is different from a thermal perspective. But it turns out the photodesorption cross-section is the same. So for a photon coming in and knocking it off, they behave basically the same. And so, if the depth, so I was wondering how, are the depths of your changes basically the same for the Mare and Highlands?
So you'd expect them to both bottom out?
Yeah, basically have the same. The same cross-section. It's
I need to double check. I'm not sure. But I will also say that we don't have tons of data. No, it does. Yeah. Okay. So it does look like the Mare values do get lower consistently.
Okay.
But it could be, we need to double check on it. It could be that we have more observations in the Mare region.
So are they normalized at some point?
This is weird talking to a box. Amanda, so the stuff, whatever it is that you're seeing that's causing your red slope, it's not ice, it's just something that's behaving kind of like it in that wavelength range. It's disappearing near noon, so I assume it's either in the exosphere or it's moving into the subsurface. So that tells me that Laddie should have seen something like a peak in a species like OH or something like that near noon. And Dana's sitting right next to you, and we can look at her and meaningfully and see what she says.
So the NMF.
Ready?
So the NMS didn't see any sort of asymmetry. Sorry, I'm too close to that mic. All right. So the NMS didn't see any sort of asymmetry in the water, the mass 18, which could have been 17 or 18. And I don't know if someone on Amanda, you want to talk about the UVS? Was there any detection at noon of OH in the exosphere? Yeah. But I mean, what Amanda showed seems to indicate that it is long-lived and mobile. It's not instantaneous, and it's moving.
But the thing is that Laddie didn't see any systematically persistent H2O or OH, whatever mass 17 and 18 are in the neutral mass spectrometer. It was very sporadic. It was sometimes there, sometimes not. So it seemed like, it was sporadic. You want the box?
I think we have a local time dependence from NMS because what I've seen is really 4 parts, you know, pre-dawn, post-dawn. And with UVS, we haven't done this analysis as a matter.
So, I mean, one of the things, and I haven't talked to Mehdi about this yet, so this may not hold for long, but what I think Laddie is seeing with the water is all of the water that it sweeps up while it's turned off. And then we turn it on and we take our water detection, and we don't know where that water came from, actually, from an entire half of an orbit. That's what I'm thinking now but yeah, we can do a little bit of work. Mehdi's been working on trying to understand the decay rate of water within the instrument, and that will help us nail that down.
Yeah, we also, I can say we, that is Tony and Mehdi and I, have a proposal funded by the Lunar program to put the 2 data sets finally together. So this is work to be done.
Rick, let me ask you a question. If you had like a fraction of a % of water being emitted, would you expect NMS to see it? Yeah, by weight of the material, yeah. That's a lot of water. So you'd expect to see it. But there you go, Tom.
Okay, so this may sound crazy, but we always measure what comes off as a desorption measurement. But you can get photo-induced diffusion. So you don't necessarily have to drive it off. The barriers for pushing that in is pretty low. So is it possible that when the sunlight is there, you're pushing it in because the penetration depth is so small that you actually move it in, and then it comes back out, but it has a tortuous path to get out, so you can have a lag time on it. So you push it in by heating it, and then over time it just comes back.
So we're just eclipse measurement. So LRO, we turn everything off except diviner. We've been leaving diviner on during eclipses to measure the cooling of the surface during eclipses. But if you can come up with a good strategy for why we would want to keep lamp on, particularly with the new mode, although I don't know what signal you'd get, but hey. It would be a challenge, though. You'd have to convince the power folks that it's going to be okay. I will say we've come through every eclipse that we've left diviner on in very good shape with no major concerns, but something to think about for sure. Back to Tim.
Tom, your comment brought me back to my comment about this temperature gradient we see in the lunar regolith. So if you are at the very surface and you go down 1 micron, the temperature might be 10 degrees warmer. Down 10 microns, it might be 100 degrees warmer, something like that. Maybe not quite that high, but at what point, do you reach a barrier where it becomes much more efficient to go up instead of down? Do you have a sense of that?
I wish I had a better sense of it. It's something you left out of the model. The short answer is no. There's a gradient, and for us, in our model, we actually don't deal with the diffusion of water. Right? This is for molecular diffusion, because we don't think water's there very long or there at all. And so for us, it's the diffusion of the hydrogen that's on the OH. And the way that that diffuses is a very complicated hopping process of the hydrogen from one oxygen atom to the next. And that's pretty slow. And those rates are so slow that even that temperature gradient probably won't affect that diffusion rate or that transport rate. It's really transport. It's not really good to call it diffusion. But that's a very interesting question. Where we've been thinking about that actually is I believe methane's there, okay? And that would be going in. That runs around, okay? So that diffusion rate is pretty fast, and that might be doing something. And so, but I don't know how to, I don't.
Here we go. Here's the thing. It wouldn't be leaving as water, it'd be leaving as hydrogen if it's getting photodissociated, right?
Yeah,